record button I found. That's good. Now the microphone. Okay, I only could switch off my own.
Yes, Christoph, it is now recording.
Yes, and I think I'm finding now the option to close the microphones, although no. No, I don't find it. The only option that I found is that to allow attendees to turn on their microphone, which should be possible, but I don't know how to put them off. Okay, sorry, I don't find it, Jesus. For the time being, I don't find it.
Don't worry, just
Yeah,
continue. I think now
yeah,
that we won't have a new participants joining.
yeah. Okay, indeed. So where was I? So you have to then create out of the the free fields here this this string of 36 characters, which you then have to convert to the so-called base 32 encoded characters. So we have then in total, well, obviously 36 how to say characters, and then this is your string, so to say. So all of this is actually according to RFC 4648, which is probably more better explained than I just did now. So therefore, I put it also on the slide here. Well, that's it actually. So you end up then in either 6x6 characters that you have to enter in the ETS dialog that I have just shown you. Or of course, you convert this string into a so-called QR code version 2, which is a 25 by 25 dimension. And also this is supported by ETS. So if you have a camera, then you can scan and yeah, the certificate is then added to the ETS project. So, okay, I'll guess this is clear unless someone, no, apparently not. Nothing in the chat box either. Okay. Next slide. The actual stack extension. So indeed, if you look up in the application note that I mentioned, 158, you'll find also this picture. So I have, okay, I have it from there. It's indeed truly an extension of the application layer. So we have actually put an extra layer, a sub-layer if you want, underneath the already existing plain application layer. So which was just called application layer. We called it plain, and then we added the secure one. And this is exactly what I try to explain to you. So this part here, what does it take? What is required to add this in your existing plain device? So into the details. So first of all, the first thing that you need to take care of is that your device is able to process so-called extended frames. Most of the plain devices out there still are still only able to well, maybe most of them, I don't know, to be honest, but still a lot of them, let me put it like that, are only able to process so-called standard frames, which means they have a limited the payload length is actually limited to maximum 15 bytes. That's actually what it means. So we need more. We need more than this 15. So the more, the better, I would say in this case. 15 is really an absolute minimum here, or yeah, 16 actually. So that's the first thing. So you need to support, the device needs to support extended frames. Then the device also needs to be able to distinguish. So once it is indeed able to support extended frames, it should also be able to recognize how to say encrypted frames. So to how to say, to distinguish the plain ones from the secure ones. How does it do that? Well, there's a specific field for that. So it's called the APCI. In case you're not familiar with that yet, an APCI is just a code for for the service that is encapsulated in the telegram. A group value write, a group value read, a memory write, a memory read, a property write, a property read. All of those services have an own specific APCI. And in order to distinguish, let's say, the plain ones from secure, it's the same principle. Just use this field, and if this field has the value 03 F1 hexadecimal, well, then it's a secure frame. As simple as that. Of course, the secure frames, they actually encapsulate an encrypted plain frame. So it could be an encrypted group value write, a group value read, a memory write, a memory read. All of those are then encrypted, but they all have the same APCI, however. It's always 03F1. So you only find out the real APCI, so to say, after the decryption. I guess that's actually quite obvious. So the 03F1 is definitely something to remember. I will also show that later on when I let's say when I test it with KNX Virtual. When we analyze a telegram together. Okay, so if also this is how to say accomplished, so so you can distinguish plain from secure frames. Sorry. Then next step is to decrypt, of course, such telegram. And this is always done based on the tool key. So the tool key, indeed, one. There's just one tool key per device. This tool key is automatically calculated or selected, if you want, by ETS from the moment you add the secure device to the ETS project. So it's not even something you can influence as an ETS user. ETS is just doing that automatically. So it's of course a secretive data of the ETS project. So it's totally hidden from the ETS user. And again, automatically chosen, so to say, by ETS. Of course, when ETS is going to make contact with the target device, with your secure device, the first time, there of course needs to be a so-called shared key or an FDSK. The factory default setup key needs to be used. But this is of course only for the, as I said, for the initial the initial communication, so the first handshake actually. And as just explained before, this FDSK is actually known to ETS thanks to the certificate that has been added. So we just made a calculation. So that means after adding the certification, ETS has the serial number of the device and has its FDSK, so its initial key. And that means it has everything on board in order to make that first contact, in order to make that first handshake. And when this handshake is successful, then ETS will automatically change this FDSK with the tool key that it has selected for that device, and it will make sure that the tool key is also set properly into device, into the target device. So that means after the first handshake, ETS will indeed, from that moment onward, use the secretive tool key in order to contact the device, in order to commission the device, in order to do whatever business it has with that device from that moment onward. So that is also something that, well, obviously needs to be, added to the stack. So all that handling of the tool key. Next step is then to distinguish, let's say, the different types of data security telegrams that exist. Well, there are actually only so to say two categories to distinguish. It's data versus sync versus synchronization. So data is actually the type that will be used for in order to commission the device, is also the type that will be used at runtime by the device. The synchronization category is actually only used for anything related to sequence numbers. So to check the sequence numbers, to update the sequence numbers if necessary, because this is the sequence numbers are, of course, as always, the protection against the man-in-the-middle attack. So that's why we have this specific type of data security telegrams. So these are the two categories. So data and synchronization. Within data, we then need to distinguish three subtypes, if you want, and because they all need their own specific, let's say, implementation within the stack. So what are the subcategories for data? Well, it's listed on the slide here. So first of all, there's broadcast, multicast, and unicast. In synchronization, we actually have the same, except we will never see multicast, the multicast subtype here. So only broadcast and unicast. So unless you interrupt me, I'll just continue. So to go a bit deeper in those subcategories, so if I look at data broadcast, so their specific, let's say, purpose is to set the individual address of the device, or to read the individual address of the device. So for twisted pair devices, this is done by means of a service called IA write via the serial number of the device, and reading is also the same. I read serial number for the open media devices. So concretely the IP devices and the radio frequency devices. the individual address is written or read by means of the domain address of the device. So, so those are the services that also need to be implemented, again, under the subcategory of a data broadcast telegram. Data multicast then is actually, well, multicast is in this context, of course, nothing else than that we already know from the plain context, from the plain mode. This is all about group communication. So concretely, what needs to be done in order to process a data multicast telegram to process it properly? Well, a few things that I put here on the slide that need indeed attention are example given. So I just only listed 3. There's of course more, but those are the 3 most important ones, I guess, at least. So first of all, if the data multicast telegram is decrypted, you can find out if this group address is indeed in the group key table. So the telegram that was received for that group address was indeed an encrypted telegram. This group address that you found in that encrypted telegram is in the group key table. Well, then you can safely process this telegram. So you can decrypt it and do the rest of the business in the stack. If the telegram, however, is an encrypted one, but the group address that was in that encrypted telegram is not in the group key table, well, that is not a good sign. Then you should not process this telegram, because then it seems to be that something was wrong, or maybe even someone is trying to tamper with the installation. Another example there is if the telegram is not encrypted, so it's just plain. But strangely enough, the group address that was in that plain telegram is in the group key table. This is also not a good sign. So then this should not be processed either. So these are some corner cases, as we call them, that you definitely also need to take into account. Then the data unicast subcategory again needs to be divided into another subcategory, if you want, because here we need to distinguish the connectionless from the connection-oriented telegrams, because they also need they serve a specific context and therefore need to be distinguished. Well, this is all about reading memory of the device, reading properties, function properties, specific services from the device, like the confirmed restart. All that stuff is actually belonging to this category here. So the data unicast telegrams. Then still about synchronization. So as said before, we need to distinguish broadcast from unicast. Also there we see specific use cases. So needs to be implemented accordingly. And within the unicast subcategory, also there we need to distinguish connectionless from connection-oriented subcategories again. So subcategory if you want. If you do that, then you're already, I would say, more than halfway there with the implementation of the secure application layer. At least you have the, let me call it the skeleton of it. So if you really implement all of that, then well, you're more than halfway there already. Then another topic is the proxy server. So I don't know if one of you here is indeed has the ambition to also bring a proxy server to the market. Well, then there comes actually some extra complexity to the surface. Let me put it like that. So that's what I try to explain in these next coming slides here. So first thing that you need to know in the, let me call it, in the application, in the secure application layer of a proxy server, is whether the group address is in the filter table, and or whether the group address of the program of the telegram to be processed, of course, whether this group address is in the proxy table. So indeed, first of all, well, it's obvious we have, besides the filter table that we know from the plain devices, also now an extra table called the proxy table. And yeah, that's what we need to take into account when a received telegram needs to be processed. So if it's neither in the filter table nor in the proxy table, then well, it's clear. Then this telegram shall simply be blocked. So if it's coming from the primary, well, don't how to say, propagate it to the second to the secondary side, or vice versa. So it doesn't even matter whether it's plain or secure. In neither case, the telegram shall be blocked. In a normal mode, of course, as you know, because it could also be that you, how to say, by means of the overruling parameters that you, especially in case of testing, or let's say in case of, I don't know, building up the installation, then it could be, of course, that the ETS user opts to not use the normal mode of the device, but to just open it for any telegram, so not to apply any filtering whatsoever. That is, of course, also still possible here. So what I'm talking about is of course the normal mode, so where the filter table is supposed to be used. That, I hope that is, of course, clear. So in the other cases, so what we need to distinguish in the table here is where the group address of the received telegram is in the filter table, but not in the proxy table. Well, in that case, whether it's plain or secure, it doesn't matter. The telegram shall be forwarded. So that is the second rule. And then if the group address is in the filter table and the group address is also in the proxy table, well then, and whether it's plain or secure, so also that doesn't matter, then it needs a very specific processing. So let's go to the next slides indeed to find out what this means. Because here it's a bit indeed more complicated. So first case, let's suppose that the received telegram is received at the primary side of the proxy server. So we need to, first of all, distinguish whether the received telegram is a plain one or a secure one. So that's the first thing we need to know. And then we need to look at the specific situation as it is actually created by the ETS user for this group address and for this proxy server. So we need to look at the primary, secondary constellation, if you want, in how it is actually created by the ETS user. So concretely, what does it mean? If there's a plain telegram received at the primary site, and if the ETS user has defined that the group the telegrams for this group address are indeed supposed to be plain on the primary site of this proxy, and they are also supposed to be plain on the secondary site of this proxy server, well, then it's clear. Then the proxy server knows what to do. In such a case, it has to forward this this telegram. So forward means it was plain. Just keep it plain. Just forward it to the secondary site. If the telegram is, well, plain, but the ETS user has defined that it is indeed supposed to be plain at the primary, so this is as expected, and it is expected to be secure on the other side, well, then obviously the proxy server has to encrypt this telegram before forwarding. So this is actually, in those first two cases, everything actually went fine, but it can also go wrong. Because if the received telegram is plain, but the ETS user has actually defined that, well, at the primary side of this proxy server, that telegram of the telegrams for that group address are supposed to be secure. Well, then obviously we have a problem. We have a possible security issue here, or most probably as a security issue. So therefore, the proxy server shall block this telegram. Well, it's simple. The proxy server can, because of this setting, find out that something unexpected happens. So also in the case where well, obviously here we have this unexpected situation. So we have a plain telegram, we expect a secure one. That's quite normal. So that's why we block the telegram, why the proxy server has to block the telegram. But it's even in the case where where the sorry, I just need to drink a bit of water. It's just a second, please. Yeah, sorry for that. So the point that I try to make is that so even when the telegram received at the primary side is plain, and it shall be plain on the secondary side, so you could think, okay, just forward it then. Well, that's not okay, because again, because of this setting, the device knows that that telegram is supposed to be a secure one. So there is definitely something wrong. So also, even if a plain one should be the result, let me put it like that. And actually, for the secure telegrams, it's actually a similar story. So indeed, if the telegram that is received for that group address at the primary site is a secure one, and this is according to the expectations, then everything is fine. Then the proxy server just has to find out, okay, what is then the expected result on the secondary side? if this seems to be if the expectation for that group address seems to be plain, well then the secure telegram needs to decrypt it before it's forwarded. If the expectation is that it remains secure, well then in that case the proxy server only has to forward that telegram. And also here in the case of an unexpected situation, so as the table indeed says, if the telegram for that group address is supposed to be a secure one, is a secure one, but a plain as expected, well, that is not okay, and therefore the telegram shall be blocked. So this is the situation for a telegram received at the primary side, and this is the table actually for telegrams received at the secondary side. So I don't need to actually go or repeat all of this here, because it is indeed actually a repetition of the same principle. So so of course also example given if the message, the telegram for that group address is a plain one, then the proxy server has to check what is to be expected. If this is also plain, then everything is fine, or vice versa. It's secure and it's supposed to be secure, then everything is fine. Then the proxy server just has to check, okay, what is then expected in this case at the primary side, and then react accordingly. Either encrypt it, decrypt it, forward it, or block it. That's actually all the same. We just need to, how to say, the point that I want to make is that this is a quite, how to say, complex detail of this proxy server, because it takes an entire table to cover all these different cases, and again in each direction this needs to be set up. So that's for the proxy server. I still didn't get any question in the chat box. Nobody interrupted me on the microphone, so I guess that means that everything is clear so far. Is this really the case? Nobody has a question?
I just written a question in the chat. Do you see it?
Oh, sorry. Really? Then I have missed that. Okay, I'm sorry. Okay, I should scroll.
So
Of course.
My question basically is the proxy server has to perform the encryption and decryption for the telegrams if he is configured to do so.
Yeah.
And for to be able to do this, it has to store all the device specific keys. Is that correct?
Yes, of course. It's well, of course, the proxy server as such has its own tool key, obviously. But that's not your question, I think. But indeed, besides that tool key, which is an obvious thing, it also needs indeed the group key for all these group addresses that it is supposed to to treat.
Okay. Yeah.
Because that's maybe something I did not say or did not mention so far. Well, I did not mention it yet, indeed. So indeed, if we just look into the ETS project, and there are two secure devices that communicate with one another. Let's say, push button and a switch activator, most obvious example. And there are two objects that share this same group address. Then, of course, both these devices, so the push button and the switch actuator, they both need, of course, to know the group key for that group address. So that is, of course, that is, of course, what is supposed to happen there. So they both need to know that group key. If there is a proxy server in between, that should also, how to say, take that into account, that group address, if it shall take that into account regarding security. Then, of course, also this proxy server or proxy servers, it could be a chain, it could be more than one. Then all of them need to know that same group key. That is indeed the requirement. Okay, if besides that there are no questions, and now I made sure I scroll down the chat box. Nothing, okay. Then, okay, then let's continue. Because I think I can then, just hang on, if I just show you again the overview. Then we are actually here, so the test scenario. So as I said, for me, the reason to implement this was KNX Virtual. So I also added a number of secure devices to the latest version, including including proxy servers. So we have actually there, with this KNX Virtual, actually an environment where you can learn from. So let's try that. Let me try to explain it to you how this works. So first of all, I have here, maybe that's not how I should start. Maybe I'll start with the ETS project. No, I should maybe start with KNX Virtual because I need to explain to you first how the installation actually looks like. So if you download the latest version, which is the version 2.5, then you'll have on board in this tool a number of menus that try to explain to you the situation. So one of them is this one here, the topology diagram. So this KNX Virtual 2.5 actually represents an installation that consists out of 4 segments. So the segments are here listed or shown to you. So with different colors. So there's the yellow one, the light yellow, light blue, and or cyan, I think it's called, this color, and then the regular cyan. Each with a different, it's each color is a different segment. Let me put it like that. So the first segment, the yellow one, is an IP segment. The next 2 segments are twisted pair, and there's another one, number 4. It's radio frequency. The segments are linked to one another by obviously couplers. So the link between the IP segment and the first twisted pair segment is a device called D19. D is just device, number 19. That's it. Then D5 between the 2 TP segments, and then from the TP segment, the second TP segment, to the second twisted pair segment, to the radio frequency segment, there's D18. Okay, if it's not clear because the font here is too small, well, again, my recommendation is to just get the tool yourself and open this dialog, and then you see this properly. So what is the installation that I have made with this, based on this KNX Virtual? So, well, actually, I made a link, basically a link between this device here. This is a device called D25, which is a switch actuator, a four-fold switch actuator. And it's actually in contact with this device here, which is a four-fold push button radio frequency. So that means, indeed, if I send a telegram from this push button to this switch actuator, it has to follow a certain path. So it has to pass through via D18. It will then end up in this segment. It will go through via this coupler here, D5, to this segment, and then via D19, it will end up in this IP segment. So that is in one direction. That means I'll just send a trigger command via this push button, and the switch activator will send a feedback all the way back, all the way back to the push button. So that's actually basically the function I have made. And on top of that, I also have included other devices here from the other from the other segments, which is D1 and D3, but they only participate in the trigger. So there's no feedback for them. Well, and then important detail. So device D1 and D3 are also, so it's also a push button and another switch actuator, and they are also secure devices, so they can also encrypt and decrypt telegrams. Another set of devices that I have included in this function are D4 and D7. These are also, this is also a push button and a switch actuator, but those two devices are not able to encrypt or decrypt telegrams. So they are plain devices. And also they only, participate in the trigger. So concretely, it means I have this ETS project only has two group addresses, 001 for the trigger, so for switching on the light, so to say, and 002, which is the feedback. And again, only two devices are involved in the feedback in the 002, and that is D25 and D26. So I made this exercise specifically to illustrate a few things. That is indeed to show you that despite the fact that I have here a mixture of devices being able to handle secure telegrams, able to encrypt and decrypt telegrams, and devices that are not able to encrypt and decrypt telegrams within the same group address. And that's why I, of course, need to use security proxy servers. Otherwise, this would not be possible. Otherwise, ETS would have forced me in using plain group address, plain telegrams for this group address. But it is thanks to the proxy servers that ETS did allow me to make this mixture. So ETS indeed checks the properties of the couplers that are put in between those two end devices. So D18, D15, and D19, they all three of them need to be a security proxy server. Otherwise, I could not make this mixture. Yeah. So that's actually the concept of this ETS project, and together, of course, of this KNX Virtual exercise, if I may use that word. So that is actually the diagram, the topology diagram. The actual training board is what you see here. So I have set up, as I said, a link between this. Wait, maybe I get my pen again. So between this D26 here, so 4-volt push button, as you can see, this D25, which is actually a switch actuator, D1, D3. So in the second twisted pair segment is also involved in this function, and the devices D4 and D7, which again are not which are plain devices, so not able to encrypt or decrypt telegrams. So if I now try something, so if I click these buttons here, then you will see that, okay, things are happening. I can toggle these switching actuators from from 3 push buttons. Yeah. There is, however, only one that gets feedback. The feedback, I hope you can also see that clearly on your screen, is actually how to say realized by means of this coloring. So if we see the red color in the background of the push button, then it means the light is switched on. If it's black, it means it's switched off. Yeah? And again, we only see that here in D26, so not in D1 and not in D4. Another way that let's say feature that I have added to this KNX Virtual is the so-called telegram tracer, because this also helps in understanding the situation better. So not only you as a developer, but especially for people that so installers that want to get acquainted with security or with security aspects of a KNX installation. So how does this work? Well, it's actually simple. So if I now click on a button again somewhere, then I get a trace of this. I get a trace of the telegrams. So in order to explain the telegram tracer, it's a good idea to show also at the same time the topology diagram, because of the coloring. Yeah? So we could see that indeed, if I start from the number 1, so the first telegram that appeared on the bus here, or in the installation, in the virtual installation, then then it was D26 that actually sent out a group write service. And again, the coloring is important also. So we see here cyan, which corresponds, of course, with this area. If we see light cyan, then it's this area, and so on. And yellow would then be yellow, and etc. I guess that's clear. So the first telegram that appears in the bus was indeed the one sent by D26, because I pushed the push button, and that was for group address 001. The second entry in this telegram tracer is actually the fact, just stating the fact that D26 sends out the telegram, but also receives it back. That is actually how KNX actually works. But that is just for completeness reasons that it's there, because it's not further processed. Nothing happens actually to it. You also see the hop count in this context, which is also important, because the hop count is supposed to be decremented after it has passed a coupler. as you know. So that is also something that can be found back in this Telegram tracer. So the third entry here is then D18, because this is indeed the coupler that is between the radio frequency segment and the second twisted pair. So the secondary of D18 will simply forward this this telegram, because it has been sent apparently in plain mode, because there's also a specific column indicating that. So AES, which stands for, as you know, the advanced encryption standard. So if this is applied or not is indicated in this column. So in this case, not. So that means indeed D26 actually sent out 001 as a plain telegram. According to the settings of D18, apparently for this project, D18 expects this telegram to be plain, and it also expects it will also simply send it out plain again. So it does not need to be encrypted. So therefore, the Telegram tracer just simply states that the network layer of this device forwarded the plain telegram. So nothing has changed here. D3, so that's then this device here, receives it together with D1, and they process it accordingly. So if it's D3, then also the light will be switched on or switched off accordingly. D1 as such will not do anything with this telegram because it's the push button. Then we are already here at D5, and so that's how the story actually continues, and it will go up until D19 and will end up indeed in D25. So that's all. That is what you can follow here. So from let's say from entry number 1 till entry number 10. But then of course we need to also look at what happens to 002, the feedback, because that is well, because of the fact that 001 is indeed shared amongst let's say plain devices and secure devices, this entire telegram, or all these telegrams are actually all plain telegrams. Again, the devices are D25, D1, D3, D4, D7, D25. Yeah, all of them are secure devices except for D4 and D7. Because of D4 and D7, actually, those two devices are the reason why we see here plain telegrams for the group address 001. The situation is, however, different for 002 because because for this group address, I did this intentionally, for this group address, only two devices are involved, and both these devices are secure devices. So they can encrypt and decrypt telegrams. That's what it means. And that's also the reason why in the Telegram tracer, all of a sudden the AES setting is different. So here I see A plus C, which means A is means authentication and C means confidentiality. So these are the because within AES there are actually in total 4 options for the encryption, for 4 ways to have to offer or to accomplish data security. 4 ways. The first one is, well, no security, or you have authentication, only confidentiality, or both. That is actually what we see here. So in this case, it's both A plus C. So if we look again closer to number 11 here in the telegram tracer, then this is indeed a telegram sent by D25, so this switching actuator. And again, because because the only other device is also an encrypted device involved in this group address, D25 will send it out indeed encrypted. That means that the network layer of D19, D5, and D18, all three of them will simply forward the telegram as is. So forward means it will not be decrypted here. And indeed will then end up encrypted in D26 eventually. The situation is a bit different, so we will see here any encryption or decryption whatsoever, only forwarding. That is of course different. I think if I switch on the light from yet another button, then also here that really does not make a difference indeed. But okay, just pointing out that whatever situation you create, this can be checked by this telegram tracer. So not only in the context of, let's say, of data security as such, this is I guess an interesting tool, but certainly in the context of where also proxy servers are involved, then this is also I guess an interesting instrument to help you. Well, another element, another another thing that definitely will help you here, or even which is even I could even qualify it as a necessity, is of course ETS as such. So it's not only important for the project as such, but also the monitor is absolutely key here in this story in order to understand all of this, in order to test all of this. Well, in the meantime, maybe I could clear this monitor here. In the meantime, I actually have been also recording these telegrams that were sent. So again, if I do this again, you can see if I click this button here, you will see telegrams appearing in the monitor of ETS. So the first telegram that I have sent was for 001. And if I look closer in the properties of this telegram, I can see that this is actually also because of the length. So here the first property is actually the not the payload, but the byte. The bytes of this, the raw data, that's maybe the best way I can explain it. The bytes of the actual telegram is rather short. And also, well, another obvious thing is that this security property or the security field here of this telegram is empty. So it's a plain telegram actually. This is different if I select the second one in the list. So this one. So the first one was this one. This is the second one. And here it's a bit different. First of all, it's longer. And I do have a security entry here. So it confirms that this is indeed an authentication plus confidentiality type of data security. What is also indicated here is whether the decryption was successful or not. So this is really the decryption status locally, of course. It just indicates that ETS was indeed able to decrypt this telegram, or in other words, it actually confirms that this is the ETS project for that installation. Otherwise, if it would be another installation also using group address 002, well, then probably ETS will not be able to decrypt that telegram, and then you would also recognize that in via this property here. The sequence number is also one of the fields here. We will do something with this in the next coming minutes, so where I will show you how you can get that actually from the telegram yourself. I will show you how to do that. And okay, I guess that's it. Are there any questions so far before I go into the before I really go into the details of a telegram? Any questions? Okay, then, well, there are no questions. I don't know if this is a good sign. Am I explaining it? I'm explaining it well enough, apparently. Okay. Next thing, as I said, let's have a look at indeed such an encrypted telegram. So what you can do here with this monitor is to stop the monitor. That's the first thing that you should do in order to save this recording. And what you can do with this recording, so I'll add just a second one, because I created already one yesterday. So let's create a second one, and then let's have a look. Just a moment. I'm trying to find back this this telegram trace. Oh, here it is. So as you can see here in this Notepad++, is maybe I'll make this a little bit smaller. So you will recognize the telegram. So this first telegram here is this one, which is a plain one. So again, you could check the raw data. You will see that this is exactly this telegram. The second one is then the second one in the list here as well. So also here, just because of the raw data, you will indeed recognize, okay, this is much longer. And also some details regarding decryption are also indicated here. So together with the decrypted data, and that is actually the point I try to make here. So so from the moment you start the development process, this is really a key instrument that will help you. At least in my experience, it was. So it really helped me getting through this stack extension. Because ETS indeed offers all that it takes actually. So the decrypted data then really helps understanding all of this. So let's have indeed a look at such a telegram, and then actually already in the last part of the training, I see that there is a question. Can you show us the configuration of the coupler? Okay, I think you mean in ETS. That's maybe indeed something I didn't do. Yeah, it's true. I didn't do that actually. So the ETS project as such is actually maybe I should take it from the topology view. Looks like this. So first of all, we have here this device. Let me collapse it again. So the very first device that we see is actually put right. Well, it's actually put in the backbone. So in the backbone, in case you're not sure what the backbone is, you can check here. Okay, it's indeed an IP backbone, so that's a good start. You can check its multicast address, etc. And we can see there's one device there, this device, the D25. So again, if I show you this again, then we're talking about this device here. In the backbone, there's also a twisted pair area put, which is actually created by means of D19. So in D9 in the main line of this area, we will see this device here, D19. So again, that would be this device. And underneath the let me say underneath the main line of this area, there is this twisted pair line, but also those two devices. So D4, D7, they're all here. And together with that, there's also this twisted pair line. So that is then this line. So if I also open that line, then we see in this TP line this device here, D5, right? And in the same line, I find back D1 and D3. In the same line, still in the same line, still in the same twisted pair line, there is an radio frequency segment put, which is actually represented by So this radio frequency segment, which is part of this twisted pair line, is represented or is realized by means of this coupler, this segment coupler, this D18. And in the same segment, there is then D26. So that's how the ETS project is built up. Now, for your question, how does the proxy configuration or even the coupler in general. How is this configuration done, and where is it stored, etc. Well, the first thing that I can say, well, all of this is done automatically by ETS. So that's a great thing, because if you need to do this manually, I think that's not a good idea. So it's better that we indeed have a tool for this. We have the tool. It's called ETS. So, and it's doing it. Well, as far as I know, it's doing it well. It's doing it very well. Still, however, if you want to check a few things, then this is of course possible. So let's say D18, I want to see what's going on there. Well, then you have some features in ETS to how to say, to help you. So you could do a preview filter table, and then I hope that this works. Okay, maybe. To be honest, I'm using a beta version of ETS 6, and maybe this was not a good idea to try this feature now because ETS is blocked. But okay, anyway, with this feature, maybe I just a moment. I try to get ETS back live again. Just a moment. Yeah, okay. I need to really kill it apparently. Yeah, okay. I have a fatal error. Okay, fine. Just a moment. I'm trying to launch the, let me call it the regular ETS 6, not a beta version. Maybe then things go better. Okay, anyway, I was not prepared for this situation. Unfortunately not. Well, anyway, so let me try to get this ETS back and running. If you just allow me for a couple of moments here. Still working on it, sorry. Okay. Well, okay, what I should do first is to export this project and then import it in the regular one. This will just, yeah, take too long. So please allow me to, yeah, not use that feature again. um, okay, I hope that the project opens. Yeah, okay, that's at least something. So if I go back to the topology view, yeah, you just just please take my word for it. In the released version, this works fine. So you have here for D18, you have the not only for D18, for couplers in general, of course, you have the preview filter table. So then you can already check what is in. So two aspects. You can see which group addresses are in the filter table, and you can also see the proxy table. So yeah, it's actually a pity that I cannot show it properly. Maybe if we do a small break, and if I come back after the break and try to prepare this, then maybe I could show that. Yeah, so I could do that maybe after I have finished with the, how to say, um, with the with the analysis of secure telegrams. Then I could spend some extra time for this, no problem. So then you can see how this filter table, how this preview actually looks like. Another thing, another element of this is in some cases there could be the possibility or the need to let's say to add group addresses to the filter table manually. That could of course also be. However, again, as I said, ETS takes care of all of this automatically. Yeah. But okay, anyway, if you have to, then there is this way. So you have to select the line in question, and then via the properties information, you have then a possibility to add group addresses. So maybe I'll try that. So from let's say I want to add group address number 003. Well, then you can see here the results. So this is now manually added. So that is of course also a way how you can influence the let's say the configuration of a coupler. Okay, I see that you have reacted to the chat. Yeah, okay. Don't worry. The freezing of ETS is definitely not your fault. So once the couplers are placed in the topology, the proxy table is filled automatically by ETS. Yes, that is indeed the correct conclusion. Another instrument that you have is, of course, and that should work, and I can try it. Yeah, why not? Is to get the information, so the device information. So in this case, for a coupler, for D18, yeah, which is a coupler. So let's try that, or maybe or D19, D5, doesn't matter. These are all couplers. You could also do the so-called device info, but that should be then device info with group communication. So that means this is actually a bus, a bus feature that will get the configuration as it is commissioned in the device. So that's actually the result after commissioning. Preview is the expected result before commissioning. So that's a different thing. But yeah, let's try. Maybe we can make it crash again, or maybe not. Don't know if it really is doing something here. Oh yeah, okay, I see it. A lot of telegrams passing by. So okay, so ETS is for the time being busy, which gives me maybe the opportunity to get another glass of water, if you allow me. Just a second, I'll be back. So I'm back. So here we see actually a bit of funny situation. So the monitor is still processing telegrams, although that ETS already knew the result. That can happen as well. So anyway, so we have here device info finished, and if we click on this small icon here, we can see yeah, what the situation is in the coupler. So okay, we know it's a line coupler. We know it's a mask version. Well, all that stuff is there, and we know which group addresses are in the filter table. But unfortunately, I don't find any information about the proxy. The proxy details seem not to be here in this overview. Okay, that seems to be how to say. Yeah, missing. So this ETS 6 version does not have that yet. No? But okay, anyway, then it's probably also of no use to try the preview either. So that seems to be something still missing in ETS. Although I have to be honest that I personally expected it already to be there. So it's yeah, I didn't. Well, I can only be honest. I expected it, but it seems not to be there yet. Okay, I'll check with my colleague, with the responsible colleague. So I cannot really truly show it to you, but believe me, it's supposed to be there. Okay, shall we then go into the Telegram, or are there still other questions here? Okay, apparently nothing. Okay, then let's go into the Telegram structure. So I intentionally opened the file that I have recorded yesterday, because there's already it's already a bit prepared. So it's of course very similar. So what I have done here is so into the same notepad, I just copied this this trace here, or this string. So let me maybe do that again. And I can immediately parse it into the pieces that I can recognize immediately. Because what I do recognize immediately is the sender of this, so the two addresses of the telegram, actually the device sending the telegram and the destination address. Well, it's very clear. It's very easy. This is the so the 001 is the device, so the individual address of the device sending the telegram, and 002 is indeed group address 02. Well, although I could also do that here, it's actually not a problem. Because yeah, now the telegrams are gone, of course. So okay, no problem. I'll do it again. So just to make sure that we have everything in sync, so I'll click just this button once. So that's D26. D26 has individual address 114 here. So indeed, that's what I see here in this telegram, 114. And device 001, sorry, device 001, D25 is the one that sends the group address, the telegram with group address 002, so the feedback. So that's what we clearly can see here from the ETS, from in ETS monitor. So the source address, so the field is here indicated, 114 and 001. So let's store these or save these telegrams, just those two. Okay, so I will create a third one and open it. Here we go. And then let's analyze. So this is the first one. So we can indeed see here 114 sending something for 001. I hope that you agree with me that this is this telegram. Second one, the secure one, that's what we try to understand better, is same principle. So we see here indeed the sender 001 and the destination is 002. Okay, nice. Then the next byte, the field even in this telegram, is the length, is the 0E, which indicates that we have to count from 0 to 14. So in total we have 15 bytes in the payload. You can count if you want, and you will find out indeed it's 15. The next field in this telegram is what I have been saying before. That is the APCI, which for any secure telegram, data security telegram, is 03F1. So that's what we see here. Next is actually next field is the so-called SCF. Actually, it indicates which category of data security telegram I have here. Yeah? 10, if you check in the application note 158, you will find out that it is a data security telegram, so not a synchronization. Yeah, and then you will find out that it is a multicast, etc., etc. You will find out all the details. Yeah? So it's not a synchronization. It's data, and it's multicast. That's what you will find out. The next 6 bytes are actually the sequence number, and we can check that also in the ETS in ETS monitor. So I just group them by 2 here. So let's check this sequence. This sequence of bytes. This I claim that this is the sequence number. So let's find out. So I use a calculator. Just a moment, calculator. Here we go. So these are hexadecimals. So yeah, I hope I'm right. 0, 1, 3, 0, 5, 3, 3, 4, 8, 8, and then FE. So if I change this from hex view to decimal, then I get this number, and this is the number that I should find back in the ETS monitor for this telegram. Properties, settings. So I have here a sequence number, and that should be the same as I have here in my calculator. Yeah, that seems to be the same. I don't know, I guess you cannot see it on your screen, but I see it, it's the same. So that is also something interesting to know. Then let's go to the next field. So this belongs together. Well, the next field is actually the so-called MAC. Abbreviation is stands for message authentication code, which actually has a total length of 4 bytes. Let me check if this is correct. Yes, it should be 4. So this is 1, 2, 3. No, sorry. 1, 2, 3, and 4, and they are always at the end. So it are actually, in other words, the 4 last octets that yeah, those 4 are the so-called message authentication, which again you could check by means of the application note, of course, so the interpretation of it. And then actually for the actual payload, so we have seen the sequence number. Yeah, maybe I should also say this. So the SCF it's called. I forgot the abbreviation, sorry, but you find it in the application note 158. The SCF is so 10. And we had the sequence number. So all of that. Then at the end, the 4 last ones, as I said, is the message authentication code, sorry. And then there's the payload, which is actually, those 2 bytes. So it's just 2. You need to decrypt that, and then you know what's really in this telegram. What is really in this telegram is also to find back here. So you can have this telegram here as your check, because you should actually check whether with this tool key for this device that 888 indeed is decrypted into 0080. Yeah. That's how you could do the exercise for yourself. Yes. This is yeah, how I did it. It worked for me. So I hope that yeah, with this explanation, yeah, you can also go ahead in this project. Well, as far as I'm concerned, I'm finished here. So I reached the end of the explanation. However, we have still 1 hour to go, or nearly. So we still have time. So if there is something, please let me know if I can be of any help. Are there any other further questions here? There is a way to force 2 secure devices to resync the sequence number. Yes, there's a specific service for that, and ETS, let's say, regularly uses it just to make sure that, yeah, that everything is is how to say, is going in a secure way. So yes. So the answer is yes. If the tool key is lost for some reason, can it be remade? Yes, sure. Well, this is in 2 ways. This is actually this is done. You either have the scenario where there's a factory X factory reset, so where ETS recognizes it has let's say there's this secure device which was commissioned successfully by ETS. So we added a certificate, the FDSK was exchanged by toolkey, etc., all fine. But for some reason, the device lost its settings, so it's back to X factory. Okay. Next time when ETS contacts the device, it can recognize the situation because it knows, okay, I have this serial number, I have this FDSK, and by this way, in this way, I can make contact. But this is not what I expected, so I'll check with the ETS user, and so ETS pops up a message asking, is it indeed the case that there wasn't that this device that there wasn't that it underwent a X factory reset, and then the ETS user is of course up to him, up to her to either confirm or deny this, and that is actually one way this is handled. So that means if there was indeed an X factory reset, then the ETS user just has to confirm, okay, and then this tool key will be regenerated. So that's one way. Well, and another way to regenerate this tool key is that when things are really wrong, let's say some issue with the ETS project as such, because that could also happen. It's not only the device that could have a problem, it could also be something in the ETS project, because after all, these ETS project is just a bunch of XML files, and things could go wrong there. Of course, that can happen. Yeah. So what you do there, well, then, then you need to, how to say, you need to, first of all, remove the certificate of that device that seems to be making trouble in the ETS project. well, that certificate needs to be removed. I think I even have shown you that. So if you just go here into the security details of the project, then you can, how to say, you could delete the certificates from the devices. So first of all, you need to delete the device from the project. Then you will be able to delete the certificate, and then you will be able to reinsert another instance of that device in the project, and you can start again. Yeah. So that's the second way. Factory reset. You asked the question about the X factory. Well, that is actually how to say, this is not defined by the application note 158, which means that it's up to the manufacturer to, first of all, offer it, because they could also think, they could also opt to not offer this X factory reset. And second, if it is offered, they define the way. They define how this X factory reset is accomplished. That could be, example given, holding the programming button for 10 seconds, which is then considered as an X factory. I'm just giving you an example. I don't think such an example is even implemented. But again, it's entirely up to the manufacturer. So this is not an ETS feature or anything alike. So it's not coming from ETS. It should come from the device itself. And again, is fully up to the manufacturer. Next question, related to my previous question, do you know if the sequence number resync service can be called by using Falcon SDK? I would say yes. To be honest, I'm not a Falcon SDK user, but I suppose it's that service is also there. But I cannot be 100% sure. So please, if it's missing, I guess you should report it. But again, I just assume it's there. Okay. Anything else? The certificate, yes. So there's this question about the certificate. And the question is, there are some rules about the FDSK. Okay, yeah, I understand the question. Are there some requirements regarding the FDSK, or can this be any random? Yes, indeed. For the serial number, maybe I'll start there. There, of course, a serial number is supposed to be unique. Maybe let's start already there, where the first two. So serial number is 6 octets, where the first 2 octets or bytes are actually indicating the manufacturer. It's actually the manufacturer code. So in my case, example given, KNX Virtual are actually devices, how to say, offered by KNX Association. The manufacturer code of KNX Association is 00FA. So that's what I have used in the serial number, 00FA, and then a unique number. But then indeed, you're right about the FDSK. It's as such, so you can still see it on my screen here. I use indeed, a specific order, as you can see. So something repetitive, yeah, which is of course not a good idea for real devices. Yeah, but here in this test, for this test tool, for this simulation, for this virtualization, this is of course okay. But again, just to confirm, yes, or no, better said, no, there are no specific requirements stipulated there. Okay. I'm keeping the line open just to see if there are maybe more questions. If there are, please don't hesitate. You can also use the microphone, well, if I'm not mistaken, at least. Okay, there's another question here. So about the security roles? Yeah, okay. The security roles, they actually, yeah, there you busted me with something I'm not prepared for, at least not anymore. What I remember is that you make a specific, how to say, constellation or relation between which resources, which services can be accessed in which way by whom. This is rather complicated table. And what is the question? Yeah, okay, so that is actually what the question is. Moreover, what I want to add here, it's not only for manufacture tool 5, but also for manufacture tool 6, of course. Just to be clear about that. So again, the security roles is all about, yeah, controlling who has in which way access to a specific resource. So that could be who is allowed to make a device reset? Who can do that? And so who can do that? So that is of course an individual address. How can you do that? That could be just based on authentication or maybe on both, also confidentiality. It could be who has access to the memory of the device, who can read it out, who can write it, all that stuff. That is actually the meaning, or the, let's say, the idea, or that's the role of the security roles table. Well, let me put it like that. You don't know how to use it by the manufacturer tool. Well, as I said, I have to be honest with you. I'm not prepared for this specific question because it's not really a stack extension, which I don't want to use as an excuse here. Just explaining you why I'm not prepared. So if you do have that question, if you really are in trouble because of that, please don't hesitate. Open a support ticket. And then we'll take it from there. Again, you should, first of all, you should use manufacture tool 6. That is the first recommendation. And second, if you really don't understand how it's accomplished there, then please contact us. We'll check. Because maybe something is missing. I mean, I'm not going to say that manufacture tool is perfect or anything, because it could still be missing. I mean, maybe things that you need. Okay. Anything else? All right. I guess I guess we had the last question then. I don't know if Jesus is still around. I don't know if you still want to say something, because if there are no questions, I think I can close the line here or close the session. Would that be okay? No questions? Okay, yeah, I see questions regarding the slides, the recording. Well, that is something we can provide for, of course. Especially Jesus is taking care of that, so he will probably contact me as well for this. He will contact me for that anyway. I know him. uh, so that will also be taken care of, no problem. Okay, then I guess this is clear, because I see most of you now reacting in the chat with your gratitude messages. Thank you, etc. So that seems to be in order. Then I guess we can indeed close this class. The class is dismissed, I could say. Well, before I really close or dismiss the class, thank you very much for being here. Thank you very much for your attention. I hope that it was of some added value for you, that I contributed in some way in understanding this, and also, most of all, of course, the story doesn't end here. So please feel free to contact us again via the well-known channel, the support tickets, because that's always the best option in case we are talking about real implementations, of course, or just in general, of course. If you have understanding issues still, also then the same medium, support ticket. Well, then I think I'm finished. I'm really finished. So thanks again. Have a nice day, and goodbye.